We've come up to Alfred H Knight's today, just outside Glasgow. They provide testing services for us for our renewable fuels. The plants that we supply need to know that the fuels that they're taking in are of a particular quality, and those qualities are marked out in the contracts that we hold. We'll send you a sample of material. Could you just explain what you do to get a sample lab ready?
Depending on what kind of analysis is needed, we'll do a composition on that, and then we'll then further reduce the particle size. And then from there, we'll oven dry it, and then further reduce the particle size again.
The sample comes in, and if it needs composition analysis, then the guys, they stand at this table and they'll separate the material out into plastics, paper, metals. Prepping the sample for the chemical analysis, it's all about particle size reduction. So we need to process it through this shredder to reduce the particle size.
We're keen to make sure there's a correlation between material supplied and ETS exposure.
People are looking to see what materials are available in the waste that they can reduce that fossil carbon content. So this is an oven basically, it dries out our samples. What we do, we take 100 kilo sample mass and that's been reduced down to minus 60 mil. Nick is checking for more metal particles, so we remove any smaller pieces of metal at this stage so they don't damage the grinding equipment, and these are taken out and we weigh these metal pieces so that we know how much we've removed from the sample. So this machine now, this takes it from the minus 60 millimeters, it then goes down to minus 4 millimeters.
And so what we're ending up with is this material.
We're doing another sort just to get any last pieces of metal out of the sample, because the next stage of grinding, we take it down to 0.75 millimeters. This is the final stage to produce the lab sample.
So we'll receive the samples and we'll check what analysis they are. We take some of the material, we subsample it, and that goes through for metals analysis, and then the rest is then passed over here to carry on with the rest of the props.
That's our waste taken down to sample level. So 820 litres of capacity in the barrels that we send up tonight, and here we are with 0.76 of a gram of a vitamin pill.
Using this, we will then put this underneath the pellet, and then a spark is then come down, and then the material is ignited, and then we see what heat is given off.
It's basically the heat derived from the pellet determines the instrument to measure the calorific value.
I'm now looking at the elemental analysis, so we're looking at the carbon, hydrogen and nitrogen analysis, as well as the sulphur. We have a CHN analyser that Ryan is just preparing a capsule for now, so he's going to weigh out as close to 100 milligrams as possible. Into the capsule, you're going from 100 kilos down to 100 milligram, but that's why it's so important that front end process that you saw earlier is so important, because we need that sample to be as representative as we can possibly get it.
So the measurements we're getting from this instrument are measurements for what elements?
Carbon, hydrogen and nitrogen.
So we're doing trace metal extraction in this lab. It's all done in the fume hood here. We use the microwave extractor to digest our metals. We weigh solid sample, and then we add acid, so we add a combination of HF, nitric acid and hydrogen peroxide.
And that will then give you kind of an automatic reading of those properties and the levels in the sample.
So ICP-MS, like you say, is the shorthand version of it, so it's inductively coupled plasma mass spectrometer. Essentially we turn solid samples into solution to analyse for trace metal content. As I scan across here, looking at this green line here, you can see all the different elements we test. Looking at lithium down at the low end, all the way up your kind of heavy trace metals throughout there, all your salts.
We've seen the process and the testing from start to finish. How are you gearing up for the potential implementation of ETS and what that might mean for your customers like us?
We're going to help them analyse what materials are there that they can remove and better improve their processes to help remove those materials.
Well, Sam, listen, thanks for teeing this up today. It's been an absolute eye-opener.
We've been working with you guys now for about 3.5 years. We very much look forward to working with you as the landscape of the industry evolves from there onwards.